I've started.
Okay, we're live. Okay. Welcome everybody. My name is Tom. Most of you know me already. For those who are first time here, couple of things. First of all, thank you for coming. Even though you could say the holiday season started, you prefer to be here, so you really want C++. So we're very glad. Just for the new people, we are a free weekly class. Yes, we teach people C++. You can join us most of the time here or online. And if you want the latest updates, follow me on Twitter. My nickname is XXDMS. Or you can go to our brand new website, completed to us. Thank you very much for that. And obviously, I would like to get some feedback from you. If you think something is not as good on the website that we should correct, just let us know. So we will try to make this website. Now it's based on the WordPress, so it's much more, to configure. So let us know what needs to be done. Now, I just set up. If you log on to our Slack channel, I just set up GoFundMe page. Tristan, he doesn't even know about this. His MacBook just pretty much died. I had to, in emergency mode, bring the keyboard because his keyboard just basically went berserk. So he needs to get a laptop. So if anybody is with me, we can hopefully, gather some money and help to get him replacement MacBook. Yes. So anybody who wishes, go and help us. RSVP. You're very welcome to RSVP for other classes. Yes, or if you know that you're not going anywhere, as some other students suggest, you can, RSVP for as many classes. The more of us is coming, then basically we get a better chance of getting nice big spaces rather than sit in a cupboard FN room. I have a bunch of new licenses, so I got plenty of licenses. If you need a license, send me an email. So in the subject put C-Lion license, so I can find this easy because I got thousands of emails. And in the body, just put your name, surname, and email address. So that basically allows me easily copy and paste and just send you a copy. Finally, please stick your name. There should be somewhere a list. Please stick your name. Yes. If there is any mistake with spelling, just correct it. If you're a new person and your name is not there, just scribble down with a pen, and I will collect that by the end, and I will update the people who are coming. After class, obviously, we're going to pub. Everybody is welcome. You can buy these two guys a couple of beers, and share your experience with C++. And that's all from me for now, and I'm passing you to Tristan. Thanks.
Okay, good evening, everybody. Nice to see so many people here. We were feeling a bit lonely last week, but everyone's come back, so welcome. Yes, a bit embarrassing, the whole fund me thing. But anyway, as Tom said, my laptop keyboard decided it didn't want to work anymore as I was preparing the slides for today. So fortunately, Tom has come to the rescue with this, but it does mean that I'm a little less prefer to be. So we'll get through it. Luckily, I still had a lot of the material ready from last week. So this might be a bit rough and rushed, but we'll see. Hopefully it'll be all right. Let's go through the things we go through every week at the start. Which is, so is anybody new? Is it anybody the very first time? Hello, welcome. I think you might be lying, Justin. Thanks. Just because you don't know C++, it's not your first time. Yes, so as you will have gathered, you've joined us in session 14. So we're going to be going on from the stuff we did last week. So if you already know some C++, you know, you're welcome to join us. Join in. Otherwise, it's probably going to be a bit of a steep hill at this point. But we do have all our previous material is available on our GitHub page. You can take a look at that, or as I say, if you've got some C++ experience already, we're here. Me, Ollie, this chap in the hat, and Justin in the front row, who's also his first time, allegedly. But we can help you out with if you want how to get started and all of that. We do have a Slack channel that I promote every week, and nobody ever joins, but I'll do it again. Please do join us because it's good for class notifications, if nothing else. Emails have a nasty habit of going to people's spam folders for some reason, so if you keep an eye on the Slack, that's a good way to do it. So just go to that URL, enter your email address, and it will send you an invitation to join our very exclusive club. In theory, we're using this textbook, which we have used very much actually in the past 14 weeks. But if you want to get a copy, it's available on Amazon, or there are ebook versions. We will, at some point, start using it a bit more heavily than we have so far. Right, let's get on and talk about that. That's the preliminary stuff. So if you haven't been before, I'd say more or less the same thing every single week. So 90% of the class is just turned off already, but never mind. So last week, for most of the people who weren't here, oh yeah, sorry, you've got to say this like internally in your like film trailer voice. Previously, C++. Yeah, that's the one. So we talked about explicit constructors, we talked about member initializer lists, we talked about copy constructors. We're going through classes, structs, initialization, constructing, destructing, copying your own custom types. There are things called the special member functions. That was last week. For this session, these are the things I prepared. Well, mostly prepared, as we mentioned. I've had to rush a couple of them, but I doubt we'll get through it all. But we'll see how far down the list we make it. If we race through it and we get through all the exercises in double quick time, we can cover all of this, I reckon. Does that sound good? Yeah, excellent. All right. Let's start off with a bit of revision from last week. So, somebody who was here last week, can you tell me what do I mean by an explicit constructor? Or even somebody who wasn't here last week, if you happen to know it already.
Is something, according to you, that's pretty nasty?
No, I say explicit constructors are nice. I say the opposite is nasty. Implicit constructors, implicit conversions are nasty. Okay, so if we write a constructor that takes a single argument of a certain type, then we can use that constructor to convert from the first type to the second type. We sometimes call these things converting constructors. Conversion constructors. So type B has a constructor that takes as an argument a type A. Then we can convert an A into a B. And when we have one of these constructors, a constructor taking a single argument, C++, the compiler, can use these kind of magically to do something called implicit conversions. So the most common way you'll encounter this is if you have a function that takes a type B and you pass it an instance of an A, it will magically, behind the scenes, use this converting constructor in order to change or create a new temporary instance of this type in order to let you call the function. That sounds a bit wordy and mysterious, so let me show you an example instead. So I have this our usual struct example because I suck at naming things. So here we have a constructor, for our class example, that takes an int, single argument constructor. So it's a candidate for a conversion. And now we have a function called func, because again, I suck at naming things, which takes as an argument an example, a const reference in this case to an example. And now we call this function with an int. And that's okay, this will work. And that's a bit weird. Because what's happening is the compiler's looking at this and going, okay, you're calling a function called func, and you're giving me an int. And it'll say, first of all, is there a version of func that takes an int as an argument? No, there's not. Well, what versions of func do I have? Okay, I've got this one that takes an example. Can I convert an int into an example? Well, yes, I can, magically using this constructor.
Is that because in the implementation of the example constructor that we can't see, you've told it how to convert into an int?
The constructor will do something with that. Maybe it has a member variable that's an int that it's setting. It doesn't. The implementation of the constructor doesn't matter, only the signature. This is all the compiler needs to see in order to try and make it an implicit conversion.
Sure, but I'm just wondering how. I wasn't here last week, so I won't keep sort of hanging on about it. I'm just wondering.
No, that's okay. Rather, so you're wondering kind of what this constructor does.
Yeah.
It doesn't matter. It could just throw that int away.
Okay.
What the compiler is looking for, it's going to try really hard to let you call to make this call work. And so it's going to say, is there any way I can convert this 3 into an example so I can call this version of the function? And to do that, there are a few ways actually that it will try and do conversions, but one of them is by using a converting constructor, a single argument constructor like this.
Oh wait, no, it creates the example because it's
uses the constructor to create a new
and the
instance of an example
creates
and
an
passes
example.
that to the function call. Yes, that's exactly what happens.
If you think of it this way, it doesn't matter what that constructor does. That's up to you.
It's always
The
going to
compiler's
return
job
an
is
example anyway.
The compiler's job is just to find a match. Also, most importantly, this only works if func takes either const example ref, const example and, or example. If you just do the example and, it would not work.
Okay.
Our value ref would work as well if you.
Or not, would not value ref work?
Pretty sure.
It would.
Yeah, because anyway, this is what's called an implicit conversion, right? Because we're not explicitly converting this int into an example. It's happening behind the scenes for us. It's happening implicitly. This is called an implicit conversion. And I don't know why the code disappears from my slides, but there we are. Now these implicit conversions are kind of weird and mysterious, and generally we don't like them. They are very often unintended, and you can end up calling a version of the function that you didn't want to call. Fortunately, we can disable the use of a single argument constructor as a conversion by using the keyword explicit. So what we do is we have our struct example again, and this time we've written the word explicit in front of the constructor name, in front of the constructor signature. That's the only change. We haven't had to change the implementation of the constructor. Whatever it doesn't matter. It's only the signature that changes. And now we have the same setup. We have our func that takes an example. But what happens this time? This compiler goes through exactly the same process. It goes, okay, I've got this call for a function called func. I'm being passed an int. Is there a version of func that takes an int? No, there isn't. Okay, but I've got a function that takes an example. Can I somehow convert this int into an example? But it's going to look at this constructor and go, okay, this constructor was marked explicit, so I can't use this to form what's called a conversion sequence. It's going to reject using that. So now, when we try and call this, we're going to get a compile error. And that's a good thing. Because maybe the user thought they were trying to call a version of func that took an int. They didn't know. There were no, this bit was in some header file hidden away somewhere, you would never know there are any examples involved in this line of code at all. So how do we call this function? Well, we have to explicitly convert our 3 into an example. So we call the example constructor. In this case, I've used curly brackets. I could have used round brackets. Because, as we discussed many weeks ago, initialization in C++ is a bit mad. So what's happening here is I'm explicitly creating an instance of example with which I'm passing to this function. And this is better, because now, if you imagine this bit was hidden away in a header file somewhere. Now, at the point at which we're calling this, we can see that we're using an instance of this example class. And again, the code disappears. I don't know, sorry. Get into the habit of marking all your single argument constructors with the word explicit. Right? This is one of those cases where C++ got the defaults wrong. Usually, we don't want an implicit conversion. Usually, we want things to be explicit. There are a few cases where an implicit conversion is very useful. For example, the standard string has an implicit conversion from a string literal, and that's quite useful. But most of the time, these implicit conversions are unintended and mysterious and not what you want. So to avoid them, it becomes a reflex, right? When you've written C++ for a while, every time you write a constructor that takes one argument, you put the word explicit in front of it. So it's just a really good habit to get into. So that's explicit constructors. Moving on. This is still last week's material, but lots of people here who weren't here last week. Let's talk about member initializer lists. So again, somebody who was here, can you tell me what a member initializer list is? Structure initializer list, if you prefer.
It just defines the variables that you're using in your struct.
Defines the variables?
Initializes.
Initializes the variables.
I didn't want to use initial.
Initializes your member variables. Exactly. So, why do we have these constructor functions in the first place? The job of a constructor is to make your class ready for use. Right? And part of that job is initializing your member variables. Now, your member variables themselves could be classes that have constructors that take particular arguments. So you have to initialize those members by calling constructors, and as we've seen, constructors can be overloaded, can have different ones, take different sets of arguments. You want to be able to choose which constructor you're using for your member variables. And we can do this in what's called the member initializer list. So the way we write this is in our constructor definition, so not the declaration, the definition, before the opening brace, we put a colon, and then the list of members, we call their constructors. So again, I'll show you an example. This time we have our struct example. It's got two members, int and float, mem1 and mem2. And now we've got a constructor, which takes an int I and a float f. And what we want to do in this case is to initialize mem1 so that it's set to I, and mem2 so that it's set to f. So the way we write this is we put a colon, and we write the name of the member, and we pass its constructor arguments. Now in this case, int doesn't really have a constructor, but it's the same syntax to initialize this int. Again, we could use round brackets here instead. And in some strange cases, like standard vector, that makes a difference. In this case, it doesn't. So here what we're saying is initialize member1 with I, and initialize mem2 with f. Does that make sense?
But when you call example, that will change if you put in. You change it when you call example in your program. It's just the initial.
So in my program, if I call example brackets 3, 4, then what's going to happen is the constructor's going to get to here. It's going to say, okay, I've got my I is 3 and f is 4. So I'm going to initialize mem1 with 3 and mem2 with 4. Close the class because it was bothering me.
Yeah.
So this thing, because it's got these empty braces, this is the definition of a constructor. Now, if you remember, constructors, as with all member functions, we can write them in the class, as we have here, or we can write them outside the class.
Oh, so those curly braces are basically an empty block, which is to contain what the constructor actually does.
Exactly that, yes. This is an empty block. This is the body of the constructor, which in this case is empty. Because all the work we wanted to do, which was setting up these member variables, we've done it in the initializer list. There is nothing to do in the body of this. Yes?
Is there a significant advantage to doing it via member initializer list versus sending it to the body of the constructor?
Yes, there is. I'm glad you asked. The way C++ works, when we get to the body of the constructor, all your member variables will have been initialized, one way or the other, right? So if we didn't have this, if we didn't have the member initializer, then when we got in here, these would be set to junk values, and we'd be overwriting that junk. Now, for ints and floats, that doesn't make a big difference. But if you imagine you had something like a string here, what we've had to do is default construct that string, first of all, and then immediately overwrite that. Right, so it's wasteful. We're doing effectively two initializations. Whereas if you do it in the member initializer list, that initial default construction step never happens. Right? They are born with these values in them. Even more than that is sometimes you can have member variables which don't have default constructors, which can't be initialized with no arguments. And in that case, you have to use the member initializer list. There's no other way to initialize your members. And the third reason, if either of these were const, because you can have const members, then a const type we can only initialize, we can only write to it once when we create it. After that, it's immutable. We can never change it. So if we didn't have an initializer list, it would be const initialized to rubbish. In fact, you get a compile error for an int, but hypothetically, we'd be stuck with that. We could try and write to it in the body of the constructor, and it would tell us, well, this thing's const. You can't modify it.
You wouldn't even get that far. If it was const and you didn't, if it was a const ref, it would just fail. You have to to use the initializer list or it won't compile.
Yeah.
Yeah.
So, always initialize your member variables using a member initializer list. Always use an initializer list. This pattern that you see here of doing all the work in the initializer list and then having an empty body, that is really, really common. Okay, you see it all over the place. When we get on to talking about inheritance, you also use this same syntax for initializing your base classes. But we'll talk about that hopefully next week. We'll see how far we get tonight. Getting disappearing slides. So is that, well, until I deleted it, was that all reasonably clear?
So as you said that we can have another variable that we don't define. So for example here, if I write example int I float f and something else.
Yeah, string
And
S.
then at the bottom we have to write it as a mem or something because we didn't define it. So
I see what you mean.
Yeah, okay, so if there was a third argument to this constructor, we wouldn't necessarily have to use that argument. So,
so you only use these two arguments because you want to introduce.
yeah, because I want to initialize my first member and my second member.
So we can have more and then not define.
Yes, you don't have to do a straight copy like this. So if I wanted to, I can say mem1 equals I plus I, and put I plus I in these brackets. And I could say mem2, and then in these brackets I could do 2 times f, for example. So very often you'll see it, and it's just a straight copy of the arguments you've been given. But you can do more interesting things. You can call functions in these initializers, for example.
Can you overload the example?
Of course, you can always overload different constructors. Yes.
This is probably a good example of a usage case as well. What you can do is you can have just declare some arbitrary structs, right? So you have like a struct A, a struct B, and then to force the user of your class to use the correct type, the third argument will take an A, and on one overload, and the third argument of another overload, so it'll be int I float f, will take a B. So then you've got int I float of A, int I float f, and then B, right? So you still pass your int and your float, but because they take these 2 types that you actually throw away, right?
Yeah,
you just throw them away. It now means that the compiler has a way to select the correct constructor, and even though that type does nothing, contains nothing, because it's a specific
It's
type.
called a
of design,
tag type.
It's a tag, effectively, yes. The
And
standard
then
library
you
uses
can have a different inside a function.
Yeah. So, for example, in atomics for multi-threading, they do exactly this. You can say you use like std memory order strong for what's called strong memory ordering. So this is kind of advanced multi-threading topic, but the idea is that it guarantees that orders operations happen, so that if one thing is already written to a value, it's ordered so that anything they're reading from it's guaranteed to get the new value. If you do memory order relaxed, it might get the old value. And this is literally just using types in this very way.
So if you remember, we can also have what are called in-class initializers, which this is one of the things I didn't get as far as writing an example, but fortunately I have a whiteboard. I can run over here. So I use the whiteboard, so I be wasteful and kill trees. Whiteboard, do you reckon? Okay. So we've got struct S. I'm just going to do exactly what I did before, so int then 1 float then 2 We can have what are called in-class initializers. So in that case, what we do is we provide the default value in our class definition, like this. So these are called in-class initializers. So when we define our member variables, we provide the initial values here. You'll remember this? We sort of talked about this a few weeks ago. So now when we write a constructor, S, which takes no arguments, so that's an empty pair of brackets, so this is default constructor. We can write an initializer list for it that sets mem1 to 0, mem2 to, what did I write, 3.14. And then we provide this empty body. This is very standard. Okay, so this is a default constructor. What it does is it sets men1 to 0 and men2 to 3.14. But actually, we don't need this at all, because all that's doing is duplicating the work of these things. So if we don't provide a value for something in the member initializer list, it will use the in-class initializer. But on the other hand, if we want to, we can override this value using the initializer list.
Yeah, the point is it doesn't override, it doesn't duplicate the work, it just duplicates your code. The actual CPU is not doing it twice when you do this.
So now what happens when we initialize S? The compiler's going to say, okay, well I've got two member variables that I need to initialize. It's going to look through your initializer list and see, have I got, it's going to try to initialize mem1 because that's listed first. It's saying, is this listed in the member initializer list? No, it's not, so I'm going to use this value. Then it's going to come to initialize member2, and it's going to say, is it in the initializer list? Oh yes it is, so I'm going to use this value. So the member initializer list has overridden the in-class initializer. So you've got effectively two ways of almost doing the same thing. You can either write it as an in-class initializer or in the member initializer list. Why would you want this? Well, let's imagine you have, here we've just got two members, but imagine you had 20. And each and every constructor, you'd have to initialize all 20. You might have 10 different constructors. 10 different constructors, each initializing these 20 member variables, probably repeating all of that code. Whereas if we initialize them with in-class initializers, we don't have to repeat those values for each constructor. We only have to mention the ones that we want to do something different to what we wrote in the class. I'm racing through this a little bit because we didn't cover it last week. So if you want to, there's a bit more material in last week's slides, or you can watch the video. You know, haven't had enough of listening to me. Sorry, is this? Can you actually read that at the back? Just about. Okay. I'm going to use black clearly. The key point here, though, ensure that all your member variables are properly initialized. Whether that's with an in-class initializer or using a member initializer list, one way or the other, make sure that all of your member variables get properly initialized. Unfortunately, C++ doesn't enforce this, but
That's something that you would include in unit tests for a class?
It's something that's actually quite hard to do in unit tests
Okay.
because the junk value that you get might actually be the one you expect. And in fact,
Yeah.
reading from the junk value is technically undefined behavior, so your tests are at liberty to just crash as soon as you try and do it. You had a question?
So here you mention another structure, an open bracket. If we want to add another structure, shall we do the curly bracket as well? For each structure, I need a closed curly bracket.
So for each constructor,
For each S.
okay, so if you had another constructor, yes, so this empty set of curly braces is the body of the constructor, right? It's the, so we could, if we wanted
If you
to,
have another one.
I could use that again, so we can put any code we like in the curly brackets, so we could do,
Okay, I get it. Thank you.
so we can still write any code we like in the body of the constructor. But the point is, once we reach here, all our member variables will have been set up. So this is guaranteed to print 0.
Quick point about Alex's question as well. It is Alex, right? Okay, good. Undefined behavior sanitizer. When you run your tests, you run various sanitizers turned on. UV sanitizer will detect that you haven't uninitialized access and say that you shouldn't do that.
Okay.
We'll have to get you up here to talk about sanitizers.
Yeah. I've already done it at CPP, don't I?
That was going to be one of my questions about unit tests, because that sort of,
Yeah.
when Tristan mentioned that, I was like, how can you rely on unit tests then if you just get so many junk
Ways
values?
to run the
But yeah.
sanitizers.
Since everybody is so curious about unit tests, I'm curious about unit tests as well. So, are there any special structures out there to test constructors and with the implicit of explicit and initializers?
So testing whether your constructor is explicit or not is possible, and it's possible to do it at compile time. You don't even need to run a unit test. You can do it purely by pressing compile and have it tell you yes or no. It's a bit...
It actually did the implicit thing that I did not catch.
Yes, exactly. Though you have to write a test to say, if I call, can I call this constructor implicitly? Which is, in order to do that, you have to know which constructor you want to call, in which case you might as well just look in your class definition and make sure you put the word explicit, right?
That's
Yeah,
the
I was
problem.
going to say this.
Sometimes you not write code that you're using other people's libraries.
Yes.
So you get into an error.
But when you're using other people's libraries, the general,
You will be
For
given the
example,
header, which will have the...
but also you wouldn't test another person's library. You wouldn't write test in the code that the kind of coding that I do professionally. That's not what we do. I don't know if that changes with.
I wouldn't do that.
No, you rely on the fact that the creators of the external library have tested their code properly.
I mean, obviously you want integration tests, but not unit
Yeah.
Finally, in our little revision section, let's talk about copy constructors. Yeah, yes.
Can you go back to
Which bit?
this? Yeah. I don't know if the order matters.
Oh, yeah, that's a good point.
Yes. Okay, yes. When the constructor comes to initialize your class, it initializes your member variables in the order in which they are declared. Right? So this will always initialize mem1 first, then mem2. And that's the case even if we wrote these the other way round in the member initializer list, it wouldn't make any difference. Mem1 will always be initialized first, and mem2 will always be initialized second. right? Initialization order is determined by the order in which you write your variables in the class, not by the order in which they appear in this list. You'll usually these days get a compiler warning if the orders are not the same, which is quite a good thing. Why does that matter? Well, imagine that we wrote these the other way around. So we did mem2 first, and then we said, okay, we'll initialize mem1 with the value of mem2. So we, again, write it over here because it's a lot easier than trying to say it in words. So now we changed our constructor so that it takes a float, f, and we say, okay, we're going to initialize member 2 with f, and then just for fun, we're going to initialize member 1 with the value of member 2. This is going to be a problem. It looks valid here. It looks okay. It looks like we're setting the value of member 2, and then we're using that value to initialize member 1. But that's not what's happening. Because the order of initialization is the order in which you declare these variables. So member 1 will always be initialized first. So what's going to happen is it's first going to run this line. It's going to try and initialize member 1 with mem 2. Mem 2 has not yet been initialized. It's full of junk. So mem 1 is going to be full of junk. Then it's going to initialize mem 2. So yes, that was a very good point and something to avoid. So the way to avoid this is always write your member initializer list in the same order in which you wrote the members in your class. As I say, generally these days compilers will give you a warning if that's not the case. So it's not something that it happens too often these days. But it used to be quite a big problem before C++ compilers got smarter. Right, where were we? Copy constructors. How many people were here in the first few weeks when I was banging on about value semantics and copies and things like that? Yeah, quite a few of you. Good. Copy constructors are, or copying things is a fundamental operation on types in C++. Right? And the fundamental assumption is once we have a copy, those copies are independent. So we change, if we copy something, we change the source, the thing we've copied doesn't change. And copy constructors give us a way to control exactly what we mean by copying. So we write a copy constructor, it uses the same syntax as a regular constructor, except the argument is a const reference to the same type. I'll put an example on the board in a second. The copy constructor is invoked automatically by the compiler whenever we're in a situation where a copy is required. So for example, if we have a function that takes its argument by value, again, if you remember from the first few weeks, when we have something by value, we're passing a copy to that function. For our own class types, that means invoking the copy constructor. So here we have, again, now we've got a func that takes example by value. Now we define our struct example. So here we've got a constructor. We know it's a constructor because it's got no return type and it's got the same name as its parent class. And the argument takes a const reference to the parent class. This is a signature of a copy constructor. And if you think about it, this is just the logical syntax for a copy constructor. Because what we're trying to do is construct a new example from an existing instance of an example that we don't want to change. Hence its const. So this is actually just a quite logical syntax for a copy constructor. So now we're going to, well, imagine this had a default constructor as well, so this would work. I mean, example E1. And now we're going to construct a new variable E2 from an E1. And I've used auto, again, I said this last week, just to keep you on your toes, so in case you'd forgotten. But you could put the word example in where auto stands there instead if this auto has thrown you a bit. But this means construct a new variable E2 as a copy of E1. Use this argument, pass this argument to the constructor. It's going to pick this constructor, the copy constructor. Now this is perhaps a more subtle version of it. Here we have this function func that takes its example by value. So when we pass E1, it's going to copy this E1 to put into this argument. And when it creates the copy, it's going to use the copy constructor that we have defined. So copying is a fundamental operation. It's a special operation. And this means that a copy constructor is one of what are called the special member functions. So for those who've been here for the last couple of weeks, what do I mean by a special member function?
The ones that compiler will automatically create.
Exactly that. So in most cases, if you don't write your own copy constructor, the compiler will generate one for you. Because this is C++, we like our types in the main to be copyable. Copying is a fundamental operation. So if you don't write a copy constructor, if you don't do anything special, you'll usually get a compiler-generated one for you. What does the compiler-generated version do? All it does is copy each of the member variables, copy construct each of the member variables in turn. So in this case, we generated copy constructor for S, which you will get. We'll simply copy construct an int, then one, and then copy constructor float. This is almost always what you want. There are reasons you might want to write a copy constructor, for example, for doing some logging, perhaps, or if you're doing some sort of low-level memory stuff, new and delete, manual memory management, then you'd have to write your own copy constructor. Most of the time, you don't need to, and that's actually something we will return to later on in this class. So that's a whistle-stop tour of what we did last week. Let's see how much of that you cottoned onto. So for the last couple of weeks, in fact, we've been...
Sorry, Tristan.
Oh, yes.
Do you need explicit for the comment?
Ah, yes. Good argument. A good question. Where did I... So, I just said to you a few minutes ago, whenever you have a single argument constructor, make it explicit. And this is a single argument constructor which is not explicit. Why is that?
What if you had another constructor that took an int?
Another constructor down here that took an int.
Yeah.
Yeah.
Then you tried to call func
Well, if that constructor wasn't explicit, it would use it as a conversion in here. Yeah? But, okay, why don't we want this to be explicit? Do you know, I've never even tried writing an explicit constructor, copy constructor, so maybe Ollie can get on Godbolt and tell me what happens. But here's what I think will happen. Is that when we try and call this, it won't work. Because just as we had in the previous example where if we had put the word explicit in there, I think you'd have to write example curly braces E1 in order to explicitly create a copy to be passed here. But I'm not 100% sure about that because, as I say, I've never actually tried it.
I think it will work, but see.
All I know is you don't make copy constructors explicit.
I need to give it a default. I think it will work. Yeah, it does work. But if you look at it this way though, I mean, if you make the copy constructor explicit, you're trying to defend yourself from people who will make their types convertible to your type. So if someone comes along and has their own struct and they have like a operator example, which is a conversion operator, so what? Like, if you're going to try and predict and harass people using your class, like, that's just silly. It's too much.
Okay, I'm going to a more persuasive example maybe. Just this has come out green just because I didn't have time to do the formatting. But this is another way of invoking the copy constructor. So create a new example. This time we called it E3 equals E2, which is a very natural syntax for copying things. It's how we copy an int, for example. This syntax, this equals something, only works for implicit constructors. So if we were to make the copy constructor explicit, this wouldn't work. And we probably do want that syntax to work because it's quite nice. It looks natural. So if we made the copy constructor explicit, we'd have to write that and not that.
Also a note for those who understand inheritance, just to mention, is if you do choose to make it explicit, it does not prevent derived classes from being passed to your copy constructor. So it's completely useless for inheritance, preventing passing copies for inheritance.
Okay, so as I said, for the last couple of weeks we've had this little, I'll hesitate to even call it a library, but a little example that we've been using with a simple two classes of points and lines, just to get some experience with writing constructors and so forth. So if you go to this URL, you can clone that. One of the things I was going to do was put it on GitHub Classroom, but then the laptop broke, so you have to do this old school and just go to that URL and clone it yourself, I'm afraid. This was people who were here last week will already have done this, or at least done this bit. But what I want you to do is to add a copy constructor to the line class that does what you expect the copy constructor to do, which that is copy the two members, but also just prints out line was copied. And then I was just going to say, and then you can see there'll be a file in there called main.cpp, which has a few test functions, or a couple of test functions that run some tests. Just add a couple of tests so that you can see when it copies.
It's as well on our Slack channel, so.
Yeah. And then if you did that last week and you're really bored, you can have a bit of revision, adding these equality and inequality operators to line. They're not really required, but I didn't want people sitting there idle. Right.
Is there a ring name?
There is no readme because my keyboard broke. Sorry.
Slide is the readme.
They have to be on Slack. Okay.
Now it's in the newsletter about. You don't know. No, I'm sure. Yeah. I'll take it.
I have to create. One second. I have to create this, but then I also have to create something in here that does that second.
So you've declared your copy construction.
Done that. But then I have to create another one of these.
Yeah, yeah.
That does start and then.
No, you need to now. You need to write this copy. You write the declaration of the copy construction in the header. You need to create a definition. See the translation. So
Yeah,
this is
so
the
I need to do
definition.
that. Yeah, so I need to create another. That's what I'm asking you. I
Yeah,
need
you've
to
already
create
got-
another definition.
This is the definition for the declaration that has start and end. Right. So you get a line of HTTP.
Yeah,
You'll see that
and
you've
then
got a
that's
declaration
the
start and end.
definition for that. And I need to create another one of this of the same signature as
That
that
this
one
one's correct.
that does
Copy.
copy. Okay.
So even though it's called the copy constructor, it follows the same exact format. If anyone needs help, just on.
They do at the end of it, so the way she's doing it. So it becomes
Damage is right.
exactly.
I see it's a task bar. Are you familiar with Git? We did some talk about
Can I just create? I'm just trying to work out what it means by. Hang on. So I just do
I don't know if you're talking to me or just talking.
I'm just trying to sound it. Okay, yeah. So, done this bit, and then I've tried to do this bit.
Okay.
So I'm trying to copy the line and return the copy, right? But it's telling me that the constructor returns void. But
That's a bit of a misleading error. Constructor doesn't return. You can use the return statement. What it does is just bail out constructor. So you see, there's no return type for constructor. It doesn't return. So what you're doing here is you're creating a new line instance. So you've taken another line, which is fine, and now here this line, line 11 is creating a new line called A. And in fact, you're trying to do that using the copy constructor. So you're going to get infinite recursion.
So I don't understand what I need to do then.
Okay,
so I need to. So I don't need to do any of this.
Nope.
So what does? But because you didn't give an example of what the copy constructor actually does.
What we want the copy constructor to do is to copy each of the member variables. So that means we've got two member variables, start and end.
Yeah.
So we want to initialize start with a copy of the other line's start. We want to initialize end with a copy of the other line's end.
Okay. So I can do that in the initializer of this rather than.
Perfect.
Yeah.
Oh, we're gonna do it in two steps. We can jump right ahead.
Do that. Why is there an underscore after this start? Do I need to put an underscore after this one as
If you
well?
look at the definition of line, I just met the with underscores because that's a very common convention for you to write the member variables.
Okay. So I need to do that then.
So the name of the member variable has an underscore after it.
Something like that.
I was trying to help you out. Skipped past it.
Oh, so have I got something wrong? Oh,
That's the one.
While everybody is busy, just a reminder: put your name on the on the list or take it. If you're not there, just write your name.
Okay.
If anybody needs a license for Sea Lion, send me an email. In a subject line, put Sea Lion license.
So
In the body of the email, your name, surname, and your email address, and I will email you back the license. My email address is tom@pcservicegroup.co.uk. Yes?
We've got this. Easy.
I've got it, but I can do it without help.
Yeah. Awesome. Well done.
Oh, I see.
Just defining the constructor.
Yeah.
Printing it.
No.
Oh no. I want to use
So essentially you need to map some modules to
Yeah, we sort of slowed down. People were like, we had quite, I guess, ambitious schedule. And we decided to slow down, a lot more examples. Yeah, so we've kind of slowed down for the initial plan. That was the feedback we got. Yeah, well, you can always follow along.
Sorry, Tom, can I catch you? Tom, what do you say regarding Sea Lion?
Email me. Subject is Sea Lion license.
Yeah.
Inside the email, your name, your surname, your email address, and my email is tom@pcservicegroup.co.uk.
I don't know. I was literally mid-sentence. Not even all of it.
What's this license for? Basically, Tom.
Okay, go to our website, cpplondon.com. You know, the website. Go to the information.
Sorry, so what was the website?
cpplondonuni.com.
You should just put line 1.
.com. Yes.
Yeah. Yeah, try Google, try
basically
firmware.
over there that you have like all the starting information.
And of course, I've rebooted, so
you can find yes,
yes,
like meeting you will find it there. Yeah, you can have something like get started.
It does. Yeah, so I actually called
.com, yes. Subscribe to our newsletter. Follow me on Twitter. My hashtag is XXEMS.
So typing my password onto a keyboard. So yeah, I managed to get in. Yeah.
London.
Basically, I've got to send you back for repair. Well, you need one of those.
Yes. Are you on Twitter?
No, I'm not. No, do you know, I work in technology. I'm really not on social network.
Twitter is very good for C++. Most of the C++
I'm pretty sure one of
people that are on Twitter.
yeah, I'll check the website out. Because it's my first time coming, I didn't know what text is. So yeah, it's good, but I probably come at bad time because like overloaded and stuff I don't.
Don't worry. I mean, we'll be restarting the course at some point.
Okay.
But don't worry, the stuff which you're seeing now doesn't disappear, it just stays with you.
Exactly.
And when you read it, then it will don't worry, it's like even if you're not paying attention now, like you're doing other stuff.
I need that.
Okay, what's the title?
I need a point. And I've got the line.
You hear like a term like
So I just want to overload the operator.
yeah, so it's like,
I can't.
I think even like this, it's really not because
I just tried to put one in.
you can't,
Oh, so this
you
is
know,
you're saying
you can't just push all the information in one
That's struct.
So where's the definition?
Point is at the
So
top.
often you hear this,
Where
like
you need a declaration.
at some point, like something that will start connecting. It is.
Yeah, exactly.
That makes sense. Yeah.
So
Don't forget you have to write.
I'll be on you got Snapple soon. One day.
You already have it there.
No, I've done
Okay,
JavaScript for a couple of years,
so-
and this is like
So here, that's where this is the thing. So I can't work out why it's not working. Sorry.
So
Yeah.
I haven't taken
No,
it
this is
seriously.
right.
Yeah.
Basically where I work,
Okay.
And there should be one. Should be one
Raise
for
that
point
here.
and one for.
Yeah.
I need to
Line.
I need to get on there. I need to learn how to
Yeah.
do it.
Yeah.
I'm trying to take
Okay.
it seriously.
this is
This lives in
pretty
point
much
of
your first
CPT.
programming language.
Yeah.
Pretty much, yeah.
This
Yeah.
is in main.
Much,
Yeah,
So I
it's
don't
a-
know.
Yeah.
The trouble is, main
So
doesn't know.
it should be declared in point,
It should be declared.
which I just tried to do, but it didn't work. So if I just take that line, it's quite a tough one.
Yes.
Yeah, I know.
You get this exactly right.
That should. I just tried. What's points here?
Just right underneath the declaration. Don't forget, it's not a member.
It's got to be outside. So it should be just. Oh, okay. Just. Oh, okay. I put it inside. That's why it went wrong. I did the same thing last week. So I did the same thing. That was why I did it again. I know I did exactly the same thing last week. I've got it. It's got to be outside.
Yeah.
No worries.
How long do these things
There's always a lot. Oh, good. Thanks for coming. And if you want to watch the YouTube,
that's a dabbled quite a bit before.
oh, you're listening to
It's really good
this was a bit whistle stop, so that was just a revision.
Yeah, no.
Yeah, no, so as I say, if you can't make it in person, you can always follow something like that.
See lines.
It's good. I like it.
Okay, better draw this to a close because otherwise we won't get onto anything more today. Who managed to successfully write a copy constructor that printed line was copied? 2, 3, 4, 5. Oh, you don't count, Justin. So again, I didn't get to writing a slide with a solution on, but I can tell you what it should look like.
It'd be better to watch it on YouTube. Are all the
class is available on YouTube now. Yeah, so watch it on YouTube. So, for those who didn't get it, what I was looking for was something like this. This would be the definition. So you'd have to put a corresponding declaration in the line class. This would be the definition. So this is saying we have a constructor called line, which belongs to class line. And it takes as an argument a reference to a const line, which in this case we've named other, just a conventional name for it. And then we have a member initializer list. And in the member initializer list, we initialize our new start member using the value of others start member, so other dot start. And we initialize our end with other dot end. So that's the member initializer list, and then in the body of the copy constructor, that's my bad handwriting, but that says line was copied, just standard printing to stand it out. We've done it 2 times. So this is really what I was looking for the copy constructor. So if you didn't use a member initializer list, well, you can. A copy constructor can use a member initializer list, just like any other constructor. So that's what I was after. Any questions about that solution for those who can read it?
I always try to relate to the testing.
Yeah.
This code, why, what would it represent something you're trying to accomplish?
So this is the code that is invoked when you are copying an instance of a type. So if you were here in the first few weeks, I had all these hand-wavy analogies about Word documents, right?
Yeah.
So this would be like, you've got a Word document that's got all your text in, and you want to clone that. You want to create a new one.
Okay.
So like on Unix, you type CP, blah, blah, blah. And you get a new document with a different name. It's a new variable, but it contains a copy of your original document.
Maybe just one part of it then. That's what the start and end means. You want you're copying the entire thing, you're saying.
So yeah, what we want our copy constructor to do is to copy the class, create a new instance that has the same value as the original. Now, a line is defined by its start and end points. So what we do is we initialize our start by copying the other's start value, and we initialize end with the other's end value.
What if you just want a portion of that original? You don't want the entire.
Then you could set, if you had other member variables that were internal and not, the terminology say, not a sort of observable part of the value of this class. So you had some sort of cache that you didn't want to copy. You could set that to, in your initializer list, to another default value.
Couldn't you put it in the body of your function? Cut inside the curly brackets.
I'm not sure what you
Where
mean.
your standard out is.
Yeah, yeah.
You've got.
What do you mean by cutting out?
You could do a substring or something of your whatever. If you say past a string of Word document or string in, is that the place to manipulate your data, or would you just take that?
In general, in your copy constructor, you should not be manipulating data. Your copy constructor should produce something that, to an end user, appears identical.
Right.
Now, there are instances in which, yes, you might have some sort of internal cache that's not visible to outside users of your class. It just is private, just to speed things up. And you might not want to copy that cache, because it might have pointers. But there are good reasons for not wanting to copy that. So in that case, you might omit it from your... It might be something that you don't copy like this. And in that case, you just initialize it to a default. You probably just have an empty cache, right?
Well, you wouldn't want to pass some type into a function and then for that type to not have some of the parameters or abilities that it would have had otherwise. So you wouldn't, when you're making a copy constructor, it should all be exactly the same, right?
Yes, exactly. So, as with many things in C++, we have the power to do whatever we want. You know, you could, as they say, fire the missiles in your copy constructor.
Just because you can doesn't mean you should.
Exactly that, exactly that. If your copy constructor does anything other than produce a new value that is, the term being semantically identical to the first one, then you're doing something wrong, right?
Yeah, but that's a good point. You just pointers.
Yes.
Because they're addresses to specific memory addresses.
Yes.
Which not really copyable as such. As they're very. They're copyable, but they're specific, aren't they, to a data set?
Yeah. So the underlying, as long as the underlying type is copyable, and it's probably again an expected behaviour is that if you invoke the copy constructor, it will allocate new memory. It will have a pointer to that new memory, and it will make a copy of whatever it's pointing to in there. That's generally an expected behaviour.
So it won't just copy the old pointer.
No. You would have to.
Yeah, so that's the case. If you were doing this memory management, manual memory management, using new and delete and things like that, then that's a case where you would have to write your own copy constructor that would.
Right.
So my real question.
Yeah.
This has nothing to do with, say, creating a web crawler. Because I wanted to create a web crawler.
It might do. It depends how you implement your web crawler.
But you're saying I shouldn't manipulate the copy, so I wouldn't really. If I copied the. Never mind.
You can manipulate, if you're building a web crawler and you want to take, so this is a different subject.
Okay. Yeah, that was fine.
Yeah, this is a
Okay.
different subject entirely.
So this is kind of low-level functionality, right? This is the fundamentals of how types work. So if you think about something like a vector, that's got somewhere stored away an array of memory stored in a heap, and that has a copy constructor that, in its copy constructor, it will allocate some new memory. It will individually copy each element of the other's array into its new array. And that's the case, again, as I say, when you're doing this manual memory management, that's the case where you would need to write your own copy constructor.
As an example of a use case for this, okay, it's probably concrete, an undo function, okay? You want to be able to undo, so inside the code, you've got, before you apply the user's change to the class, the object, you need to save a copy of its original state. So if they decide to undo, you can then just go back to that original one. So that's a concrete use case for a copy.
Yeah.
Okay.
Okay, this was the point at which my keyboard broke. So if these next couple of slides don't make any sense, that's why. I don't know if you've ever tried to do a lot of typing on the on-screen keyboard with a mouse, but it takes forever. Delegating constructors. This is some new functionality that was added in C++ 11. So if you've used older versions of C++, this might be new. So very often, I've said this quite a few times now, very often we'll have many different constructors for our classes. Might have half a dozen for a big class. And very often, almost all of these constructors will be doing the same thing, perhaps with just minor variations. And so we end up with a lot of code repetition. So as I said before, imagine you've got 20 member variables, and you've got to initialize them in the same way in almost all your constructors. So we end up with a lot of duplication of code. And then say you're doing something, or maybe, better example, you've got a lot of code in the body of your constructor. Maybe it's going out, calling out to some web service, and whatever it's doing. Something that you can't do in the initializer list. So we end up with this code duplicated in all our constructors. We don't like code duplication. So we have this new facility called Delegating Constructors, which avoids the repetition. And what that means is that we can make one constructor delegate its work to another constructor. We can call another constructor with different arguments to do the work for us. So to do this, we call the second constructor in our member initializer list. So here we have our fabulous struct example, which takes, as a constructor, taking a standard string. And now we have another constructor that takes an int. And here's where the magic happens. So in our member initializer list, we are saying, I want you to delegate to this constructor and pass it this argument. So standard toString, I'm pretty sure you can guess what that does. It converts the integer to a string. So this is going to call this constructor here. It's going to delegate to this constructor.
So you're putting in a constructor inside a constructor.
It's a fancy way for making one constructor just call another constructor.
Yes.
Fancy term.
Is it what happened when you inherit from a base class?
No, not even.
Constructor of the child class, we use of the constructor of the base.
If the base isn't default constructible, you have to pick one of the constructors of the base to call. Yes.
So it's not the same thing as calling a base class constructor, because that will be invoked first. What this is saying is that, okay, I want you to call this constructor, and then this constructor itself might initialize whatever base classes you have. Hopefully it does. Will initialize your member variables. So imagine that this class example does something complicated in this constructor. Rather than having to have an empty body here, rather than having to have an empty member initializer list and first converting to a string and then duplicating whatever work that does, we can instead just write, I want you to call this constructor, passing it standard toString. And now, just for fun, I've added a third constructor that takes a double that does exactly the same thing. It calls this string constructor, the constructor that takes a string. So it's a way of, it's not inheriting constructors. What it's doing is calling this constructor.
So you can't on that one. Could you call the second one with the third one?
Yes, so I could convert my int to a double and call this one, which would then call that one. You can chain them up like that.
Yeah.
You can.
Probably
No.
worth mentioning though, if say the first one had some code, right? The std string strip. What's going to happen is it's going to, if that had a body of code, I don't know, say it prints something to the screen, you'll see that print to the screen first, and then if int I or double D printed something as well, you'll see that next.
Yeah, so that was what I was going to say next, was remember that the initializer list is processed before we reach the body of the constructor. So what's going to happen? It will first run this, and if this did something complicated in the body, it would execute that, and only after that had finished would it execute any code that we had in here.
What if there is the argument is not you cannot convert from one to another. Let's say you have now int I, yes, and you're going to toString. What if, let's say, I don't know, let's say double. Yeah, there is, let's say you've got character that will be, let's say, I don't know.
What you're saying is what happens if this function fails?
Yeah, it's not. Yeah, it doesn't convert.
Okay, what's going to happen in that case? Standard toString. Actually, toString would never fail, but the opposite, whatever it's called, that can fail and throw an exception. And exceptions in constructors are funny things, but what will end up is that no example will be constructed. The constructor will fail.
Will you get like manageable type of error, or like,
well, it'll be an exception, so you'll manage it the way you manage exceptions with a try, block, and catch.
Oh, okay.
And if you don't have a try and catch, eventually it'll bubble up all the way to main, and your program will crash.
Yeah, I was just wondering, like, whether you get like, I don't know, 16 pages of error and like wondering what's happened, or something like more, like in a sense of like, okay, this is the problem. Look on that line. I don't like that line. Let's say line 16.
Well, in this specific example, you get an exception, so that, as I say, that would bubble up to the first try block, the first catch that could successfully handle it, and then whatever your catch did, it would execute that.
Okay, thank you.
So if you called this with say example 3,
yeah,
you'd go to the example, and it would take the 3,
yeah,
and then it would go up into the string.
Well, what it would do, you pass a 3
to the string.
You pass 3 into this function,
Yeah.
which would give you a string containing 3,
3.
and then it would pass that
Okay.
into this constructor
And do whatever
and do whatever it did in that constructor. 5 missiles or something.
And also, no, you cannot create infinite loops to compile it. So if you're
Can? Oh, I don't know.
you can't. So if you say you messed up and you forgot to put toString, so you just had example in I, and then you just call example I. Yeah, fortunately won't compile.
You say that. I think you could, for example, make these two constructors call each other, and that I don't think the compiler would catch that. So you could have an infinite loop.
If you make a loop,
This compiler delegates to this one, which delegates to that one, and you'd try and flip flop between them. I don't think that's a compiler. I don't think it can detect.
So to delegate to each other, in the int one you put example double.
Yep.
And in the double one you put example int.
Yeah. Which obviously would be a mistake, but I don't think it's something the compiler can catch. Maybe they're smart enough now.
Because the compiler has to identify unique string int double, or you can put in an additional identifier, so you can have the same ints and doubles in there.
Sorry.
So if you wanted 2 ints,
so if you
had
had
example ints,
int, comma int,
you'd add a dummy.
Well, you couldn't have 2 overloaded constructors that take the same arguments. That's not an overload. That's
you can only have one taking the same.
Yeah.
Unless you put in a dummy call.
some sort of tag type, as Ollie was saying earlier.
Also, I can say that it doesn't work. It will not create if you have two of them. So say I calls the double one, int calls the double one, and double calls the int one. It is still a compile time failure.
Try putting them in separate TEs. Don't forget, these happen to be defined in class, but I could have defined both these functions in separate translation units, and they'd have no way of knowing that it's an infinite loop. You're going to say?
In your example of having the two constructors calling, you're deliberately casting to an end and deliberately casting to an end. You can do that.
Yes, that would be a silly thing to do. Right, that was a rapid-fire introduction to delegating constructors. Let's see whether you've understood them. The line class, if you downloaded the fresh one from today, has a default constructor. What I want you to do is to change that default constructor so that it delegates to the two-argument constructor and explicitly passes a 0 point to both of those arguments. Does that make sense? Just a little example of using delegating constructors.
I've got my own
Okay.
copy thing, so I don't know what you were.
Oh well, if you just so you've got the.
Oh, I'm in my line.
Yeah, so you've got you've got a constructor that takes 2 points.
Yeah.
And you've got a default constructor.
Yeah.
What I want you to make happen is that the default constructor delegates to this constructor.
Could you put the last slide?
Maybe, but
Oh, okay.
I think people are still reading the instructions. I don't want to change it.
No, okay.
So to delegate, we write the constructor that we want to call in the member initializer. Yes. Yes. Yes, absolutely.
So in the list one you can.
In the
When
list.
you do the initialization.
So the initializer list is just the list of members. Things you want to
Then
mention.
you put the constructor, and then you don't write the body of this constructor.
I'll put the previous example up and I'll hopefully be a bit more clear. Sorry, has everybody got this? I'm going to flick to the previous slide. So if we had something in the body here, what's going to happen is first it's going to execute this constructor, and then after that has finished, it's going to execute whatever was in these braces. So in this case, it's empty because we didn't have anything to do, and it wouldn't have fitted on the slide if I did have anything to do. But it will execute this, and then once that has finished, it will do whatever is in here. Also, is that what you wanted?
Makes it a little bit easier.
Makes it a little bit easier when I put the answer on the screen, doesn't it?
Sorry.
So you are correct that you need 2 translation units, but you'd have to do it in a very insane way. You have to literally put the constructors in individual separate translation units. It's if you have the definitions in the same translation unit, it fails. So in normal usage, like who would ever declare a class header like, and then make multiple files with the different constructors?
Okay, I suspect that is something nice that either Clang or GCC is doing. I don't think it's required. In fact, I'm certain that it's not required by the standard to diagnose. Yeah, it's like you could have.
I don't have W error turned on. Right, let's have a look. Let's see.
Have you ever seen FQA, C++ FQA?
Yeah.
That guy.
Oh, that guy just hates everything C++.
I have to ask you, because in JavaScript, it seems like if I look at this code, the purpose of this code is for no matter what is passed, we want it to end up being seen as a string.
Yes.
Yes. So in JavaScript, we just say whatever string capital S, and then it would make anything a string. So this is a lot of.
So that's basically what this standard 2 string function does, right? It turns an int or a double into a string.
Yes. But this is a lot of code. Is this normal? So you really do this?
Yes.
Oh, I thought this was just perhaps.
Well, yes, this is.
Call it.
This is not
I want to call.
outrageous.
Really? Okay. Because I mean, look, you said, you know. Okay.
So I need
That was what.
you want to make your own.
I was trying to.
The sort of the strong typing does. Excuse me.
Oh, sorry.
The strong typing does lead to you writing physically more code in a lot of cases.
Are you trying to call?
Boggles my mind that you're being that explicit to say anything that, because what if you have to memorize this in double D? There are other ones like that.
Oh, there are loads.
Yes, yes.
Long, short.
They'll be converted to full stops.
Exactly. So are you writing that for each one?
Well, no. So if you wanted to have,
No matter what.
no matter what type
Yeah.
you try to convert, no. In that case, you use something called a template.
Okay.
So you just write it once.
Oh, there's
and then,
something.
yeah. That's pretty advanced stuff. Though, so,
Oh, is it?
well,
It sounds quite. So it's called C. So if I Google it, it's C++ templates.
yes.
Okay.
That's okay. Templates are amazing, and they can do incredible things.
Yeah.
And conceptually, to start off with, they're quite simple. It's just like a sort of blueprint for how to write a function or class.
Oh, awesome.
It gets very, 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 very complicated. You get into something called template metaprogramming.
Oh, that sounds bad.
Yeah, no, it is. So by all means, do Google it, and just don't be terrified by the things you might see. People delight in doing incredibly complicated things with templates.
Okay.
So yes, what you do in real life, if you wanted to convert anything into a string, you have a deterministic constructor. Any type.
And we do C++ about this for web scraping.
Web scraping?
Yeah.
I have no idea. Ollie might know better than me.
That's fine.
I don't know the sort of popular libraries for it. I can tell you for doing sort of low-level HTTP, so kind of high-level web tools.
Yeah, we mostly use Python.
Yeah.
So I wasn't sure if C++ created something.
Oh, there will certainly be libraries to do it. I'm not quite sure what the good ones are.
The thing I'm given might be constant. Whenever you want to construct it, you want constant. It will become constant by half the constructor.
So if I were to put some application to the points,
You do whatever you want because you can. Because it's your constructor, you're never calling it your constructor.
No, it's gone.
Okay, so we want to so we take our default constructor. Where's the default? That's not a default. That's a common constructor. That's not common. That's the default constructor. The default constructor is the one that takes the
so that bit counts as well.
whole thing counts as useful. The constructor.
So what we want to do is, at the moment, the default constructor is just default. Okay. So what we want to do is instead, we're going to manually write this, and we want it to So what we want to do is we want to delegate to a different constructor. So to do that, we write an initialize list. So, and then explicit. So we want to. What was the point I asked? 0, 0. So if you go back up here, go back inside that last bracket, should tell you what constructors you've got. You've got a constructor that takes 2 points. So you get it 1 point. I just want to do exactly the same again. So just type exactly the same again. No. So it's just that's the one. So you've got to get a couple of strings brackets.
So 1, 2,
That's good. That's it. That's all we wanted. So what this is saying is for our default constructor, if we're given no arguments, I want it to call this constructor and pass it 1.00, 0.00, and then it's going to jump up to this constructor. That's fine.
Oh, you just copy it to just
And it's going to run whatever this constructor does, passing it to new. Question back up. Yes, sorry.
No, John.
Is that how you want to
yeah.
So I'm just trying to, I think I've got the, so I did that in there, and then this.
Almost.
Sorry.
0, 0. That will actually work. So,
Well, so if I
the
just pass
point is 2 dimensional. So just 0, 0. You don't know the last.
oh yeah, I see what you're saying.
Just Tristan's just how we this one. I've changed it. Before it was default, but here I'm just calling down my default, which should be correct for line 0.
What you have would actually be
0.0. But now I get compiler to get it. Which is a 4 point.
I think I already had this. Oh yeah, there it is.
Okay.
If you just
This is it.
So that's line.
Oh, point is up. Points, x, y, etc.
It takes,
So line, that is now 2xy.
it has x, so x is 0, y is 0.
Yeah, which is 0 to 0.
Yeah.
Now,
I mean, it does that.
here it doesn't.
No, you're trying. That's not calling the constructor. It's calling the. Trying to find the constructor. They got one line out.
This should
I mean, you made it explicit. explicit actually breaks possible.
I get a compile error.
It's trying to find a constructor that takes a line out.
Which was the
Oh yeah, so you can't do the equal syntax with the explicit constructor.
So I have to do.
You have to use brace initialization. So you brace
Oh,
initialization.
okay, right. So it's just braces.
Yeah, I wouldn't use
Oh, for a copy constructor? No, don't make a copy constructor explicit.
Don't use explicit.
Not copy constructors. Copy constructors move constructors, the special ones.
So that's no syntax.
Yeah, it's.
You could introduce an operator equals.
We'll get to that. We'll get to that.
How so I've got to take explicit. That's correct. Mine's got to take explicit.
Oh, you mean what?
But I still can't use the equal sign. Sorry.
Is that number 8? Is line 8?
No, that's an ampersand.
Oh, okay.
An and symbol. I'm just not very good at writing them. Sorry. Yeah. So it's, that symbol means when it's attached to a type means reference. So this is reference
waving.
constant line.
Yes.
Reference. So we talked about references. I think it was week 4 or 5, way back at the beginning. So have a bit of revision.
So line class with the members line,
Yep.
there's a constructor function. Have a constructor function.
Yeah, absolutely right. Yeah. And then there's the argument. It takes an instance. It takes a reference to a constant instance of line.
Because an equal sign should be an equal sign.
Unfortunately, you'd expect it to behave just like brace initialization.
Yeah, yeah.
So, okay, so then this.
But you could, if you wanted to though, you could write class.
Line class,
You
line
could write
member
struct to do that for you.
as an argument.
If I just, I could overload the equal sign
To a const line.
in my struct.
You didn't
And
put
then
operator.
name will be given it.
Yeah. Yeah.
So that is called copy initialization.
Essentially.
Yeah, no, it's not easy to get your head around, particularly if you're used to languages that don't have this idea of giving you variables types, arguments types. This can look a bit weird.
Yeah.
So, yeah.
Because I've created a class.
Okay, we've only got 28 minutes left, so we better get on with things. Better.
Struggling this up.
Let's move on.
Struggling.
That's all right. So I'll just very quickly show you what I wanted from that. So you could define this in your class, or you could do it out of class. If it's out of class, it'll look like this. Oh, no, wait, sorry, that's completely wrong. What am I thinking? Don't worry, I'm not very with it today either.
Why is he looking at me when he says that?
It's the secret is to have the beer with you.
It's only the ball to see the ball of people.
So what we have is this is the default constructor. The default constructor is the one that takes no arguments. And what we wanted to do is we want to delegate to this other constructor that I have written for you that takes 2 arguments. So we have a constructor for our class line that takes 2 points, the start and the end point. And in this case, we want to delegate to this constructor and pass it 2 points, both of which are 0, 0. So a default constructed line has 0 length, right? It's just its start and its end point are both 0. It's kind of meaningless default value. And then the constructor body is empty. There's nothing we have to do in there. You could print something if you wanted to, just to prove to yourself it was working. And this is what I wanted you to write.
You need to put it inside the bracket, inside the braces.
Here, yeah, you could replace those with curly braces.
No, what I mean is, if you just knew some line within the body of the function, okay.
If you, in here, no, you can't, the delegated constructor must appear in the initializers. If you tried to call it here, you did this.
Yeah, basically that line.
That's just abbreviated to keep you.
Yeah.
What's going to happen here is you're going to create a new line. It's not assigned to a variable, so you're going to call this. You're going to create a new instance and then immediately throw the thing away. So this is, if you try and do it in the body, it's really not going to do what you think it is. This is equivalent to writing so if you think about what you're doing here, is you're creating a new variable called A, and you're initializing it from a line, again, imagine, I couldn't be bothered to write it out, imagine that's 6.00. This assigns this new line to a variable called A, whose type is determined by its initializer. If we omit that bit, this still calls a constructor and creates a new line, but it's not assigned to a variable. So as soon as we hit that semicolon, it gets thrown away. So this calls constructor then, as we're just about to see, maybe, immediately calls the destructor, which might occasionally be useful, but in this case is not at all doing what you think it is. This is not going to delegate. This is going to create a new instance that is immediately thrown away. So if we want to delegate, you have to do it in the initializer list.
So basically what you're doing is you're using another class's constructor to create initializer values for this.
This isn't another class's constructor, this is another one of our constructors. So this all belongs to class line.
But point is, like, are you using points constructors?
Oh, so this is where we both points constructors.
So is it similar to copy constructor? Because you're using other constructors' values?
Not really. Well, I can't remember with the two argument constructor, did I take them by value or by const reference? Const reference, I think. So there's no invocation of the copy constructors here at all. Is that right? Well,
so a copy constructor is taking copying the values of another constructor.
Yes.
And this is also taking.
No, the copy constructor copies the member variables generally.
And here we're just using another constructor.
Yes. So you don't want that. This should have an empty body because you don't need to do any more work. Saying if we're default constructing it, well, I want you to invoke that, and then you don't have to do anything further.
So I didn't do the 0, 0. I just put in some number like 3355.
Just in here, yeah.
And then I did a test case where I set the first line with 3355.
Yeah.
And the second one is the
I think we better move on because we haven't got all that much time left. Okay, let's talk about destructors. So we've talked about constructors. Constructors are special functions that construct a type, that make it ready for use. What do we think perhaps a destructor does? Destroys the type. You're actually much closer. What did you say?
The opposite.
The opposite, yes. A destructor, or the destructor, undoes what the constructor does. Right, so if you allocate memory in your constructor, your destructor deallocates it. For example, the constructor is responsible for setting up your member variables if they require special setup. If they require something special, like a delete command in your destructor, then that's the place to do it. So the destructor is a special function that is called when a type, when an instance, when an object is destroyed. Constructor is called when it's created. Destructor is called when it's destroyed. When that object's lifetime ends is a better way of saying it. Why didn't I just read that off my slide in the first place? The destructor cleans up any resources that that class might be using.
When you have, when you use in your code, let's say vectors, and you don't use new and delete, is the structure doing much, or is it more just?
We'll come to that. Well, we probably won't today now, but eventually we'll talk about it. So how do we write a destructor? Well, we write it with much the same syntax as a constructor, except that we put this little tilde symbol in front of the name. So a constructor has the same name as the parent class. The destructor has the same name as the parent class, but with this tilde character in front of it. So just to show you, a struct example, this tilde example, this is a declaration of a destructor for our example class. Now I've default constructed an example instance. So E1 is an instance, an object of type example. I've carefully put it within these inner scope. So this is a local stack object. When we hit the curly brace, closing curly brace, the destructor gets called. Again, this is going back to these value semantics that I was really hammering on about in the first few weeks, about knowing exactly when resources are required and when they're released. Deterministic destruction is one of the absolutely key things about C++. It's one of the reasons for using C++. Right, we know exactly when our objects are going to be destroyed. And not only that, we know exactly what's going to happen when they get destroyed, because what's going to happen is the destructor gets called. The destructor is responsible for cleaning up anything that we've allocated in the constructors of that type. So after the body of the destructor has run, the compiler will call the destructor for each of our member variables in turn. That cannot be avoided. There is no way that you can stop it happening. That will happen, right? It'll run the body of your destructor, and after that, it'll run the body of each of your member variables. And the reason for that is because one of the things C++ is really, really, really strict on is that the order of destruction is the reverse order of construction. So if you think about it, when I was telling you how types get constructed, first of all, it builds all your member variables, then it runs the body of your constructor. When things get destroyed, that happens in reverse. So it runs your destructor, and then it runs the destructors for each of your member variables in the reverse order that it constructed them.
So basically your destructor's body is right before everything goes away.
Yeah.
So everything's still usable.
So this means that in your body of your destructor, you are allowed to refer to your member variables. Your member variables are still alive at the point that your destructor body runs. So you could, for example, print them out, do some logging, whatever you need to do in your destructor. Your member variables are still alive. You can still refer to them.
Manually call their destructor.
No, don't do that.
I'm joking, obviously, don't do that.
So what this means is that you don't need normally. I even thought about that. Look, I put the word normally in there. You don't need to explicitly destroy your member variables. It will happen for you, actually, whether you like it or not. They will have their destructors run.
So that happens every time you go out of scope.
Every time you go out of scope, yes.
Does it happen absolutely immediately?
Absolutely immediately. There is no garbage collector, there's no delay.
So it's as though the compiler had inserted the call to destructor.
Not only as if, that is exactly what happens.
It literally does, yeah.
That is exactly what happens. So destructors are very, very special. Unlike constructors, destructors are like Highlander. There can be only one, right? There is only one destructor. It takes no arguments. You don't have to worry about multiple overloads or anything like that, because how could there be? There's no arguments that you're giving it. It's a special member function, so if you don't provide it, the compiler will provide a destructor. Actually, it'll provide a destructor that does nothing. But it will be there. It will exist. There will always be a destructor, no matter what. For every class you ever write, there will be a destructor. It's not like the situation with a copy constructor where there are, sometimes, you could explicitly delete the copy constructor. You can try explicitly deleting the destructor. And, well, that might be an interesting thing to see what happens. So really the key takeaway is that the destructor is very special, but normally, 99% of the time, you don't need to write it yourself. Normally, what you want to happen is that your member variables get destroyed. And then, if you have base classes, your base classes get destroyed, and so on. And that's exactly what happens. So most of the time, if you are writing good C++, you don't have to write your own destructor.
What about putting stuff on the heap?
If you put stuff on the heap, and you allocate with new in your constructor, then correspondingly you'd want to delete in your destructor. But in what we call modern C++, so C++ 11 and newer, you really don't want to do that explicitly. You don't want to use manual memory management like that because it's easy to get wrong. And we have these things called smart pointers that make it much easier to do these things correctly. And we're certainly going to talk about that in a future session, but the smart pointer manages that resource for you. So the smart pointer will delete it in the smart pointer's destructor. So if you have a member that is a smart pointer, say a unique pointer, it's one of the two smart pointers that are in the standard library. If you have a unique pointer member, then your destructor runs, and then your member variables get destroyed. And the unique pointer's destructor will call delete for you.
Okay.
So you don't have to worry about doing it.
Rather than if you just put a memory
It's possible to do that. It's what Vector does, for example. But you very, very rarely would ever want to do that in new code. It was what you had to do in the C++ 98 days. Very common there. You almost never want to do it today. Use smart pointers, use Vector, they'll make your life better. But yes, your point there was very important. There is no garbage collector, no background process. This happens immediately. I went on about this in the first few weeks about deterministic lifetimes. As soon as we exit the scope, as soon as the variable is no longer, when it has expired, the destructor is run there and then. So this is one of the really powerful things about C++, is this idea of deterministic lifetimes, and we never hold on to memory or whatever other resources we might have, file descriptors. We never hold on to them for longer than we need them.
But if else, because you talk about delegation, and all of the member variables will be executed. But what if you have two separate scenarios? You have like a branching situation.
Okay. So
if you don't want one to be destroyed.
So we've got if some condition, else some condition. Okay, where are we creating this variable?
In the outer scope.
Okay, so we're going to call it T. T just stands for any type. And we're going to call it T. Right? Okay, where does this variable get destroyed?
Well, we haven't written the closing code.
Exactly. We're down here somewhere, we don't know. At the end of this scope. Let's get rid of this. We'll put it in here instead. So if this condition is true and we enter this block, this variable gets created. Where does this get destroyed?
Just before the else keyword.
Here. As soon as we finish with this block, this gets destroyed. So down here, this variable no longer exists. If you try down here to say, oh, I don't know, t equals 3, that will be a compile error. That won't work because t no longer exists. T only existed in this inner scope. And we could even, if we wanted to be really sneaky about these things. Now, if this condition is true, we enter this block, we create a variable called t. But if the condition is not true, we enter this block, we create a variable called t. This is still a compile error. Because down here, there is no variable called t, because if the condition was true, we enter the block, we created the variable, we reach the end of the block, the variable got destroyed. But if the condition was false, we skip this, we went to the else block, created the variable, reached the end of the block, variable gets destroyed. Either way that this happens, there is no t. There is no t. There is no t by the time we get down here.
Where's the constructor?
Oh, well, okay. Write it like that.
And so the destructor is running automatically at the before the else. But yeah.
So this will be for people who've been coming to these for quite a while, and I'm very pleased that you seem to have got a really good handle on this. This was one of the things that I went on and on about in the first few weeks, about scopes and lifetimes and things like that. So this variable that we're defining in this block only exists within this block, between these curly braces. And the variable that we create in this block only exists within this block. When we leave, it dies. It's Destructor runs. So by the time we get down here, if we try and refer to this variable t, that's not going to work. Because there is no variable t outside of those blocks.
And delegation, the same thing would be true. If you have multiple lines of code within the if showing delegation,
I'm not sure what you mean by delegation, but if you have multiple lines of code, yeah.
We haven't written there the definition of big T. So you
No,
can't see any.
big T is any arbitrary type of a string or a vector or whatever it might be.
But that's where any delegation details of the constructor.
Yeah.
Maybe if we get over now. Oh, I see. Curly braces represent the scope.
Yeah.
So once you're outside of that, then everything that lives inside it is not accessible.
So, as I say, I'm very chuffed that a lot of you guys seem to have got a very good handle on the scopes and lifetimes of things. Right, we have 3 minutes to go. So I reckon you might be able to do some of this in the next 3 minutes. Or possibly not. But you can give it a try. The last one might be interesting. I don't want to spoil the surprise. The answer to will it compile is it depends.
It doesn't make sense. It needs to come with a structure.
Nothing to do with that. Defining a destructor as a deleted, I believe, certainly makes it non-trivial. Might probably makes it in the standard layout. So I don't know about the last one. Yes, sorry.
You maxed it out, it's gone. I mean, what are you going to do?
Well, what you would have to do is you'd have to define your variable outside of the loop. Do whatever you need to do with it in here. So you have to create it outside of it. You can't create something in the box and use it outside. It's very strict scoping.
When you combine that with what you're talking about delegation earlier.
So this is nothing to do with delegating constructors. This is.
What does he want to delegate? What does he want to do? Because the point of the delegation was you have the first set of code, which perhaps is something you
tried to put it.
Then you have another set of code, and that perhaps extends it somehow.
Okay, yeah.
So what if you have a situation where if the answer is yes, we have this.
Okay, then you couldn't use a delegating. I can see. I think I see where you're coming from now. So we're going to go back to our nice class example. Right, exactly. Okay, so that's the example of a delegated constructor. So what you're saying is if, let's say, instead of having a default constructor, let's say I had a constructor that took a bool called b. Now, depending on whether b is true or false, I want to do two different kinds of initialization. The answer is you can't do that. You can't use a delegated constructor to do that. You would have to you would probably have to do an if in the body.
Okay, so then the body.
So you wouldn't be able to do that. You wouldn't be able to conditionally initialize, conditionally call one of two different constructors depending on
And the deconstructor.
destructor.
This destructor is going to be the.
So the constructor, this is a constructor, right? So when we create an instance of line, it's going to call a line constructor.
Yes.
When we finish with a line, when it goes out of scope, it's going to call the destructor.
At the bottom.
No. This is a constructor. This is the function that gets run when a line is created. We haven't shown who is calling this. Let's go back to the implicit default. Right. So this is the line default constructor.
Yeah.
Now I'm going to write a line destructor as well.
Did you put in?
It does not.
Did you put it in the head?
I just put it straight in the class.
Yeah.
But it's
So now, somewhere else in my code.
Yeah, I did that because I couldn't.
I've got
get
it.
it
You
to
just
work.
put
I
STD
just
out.
put it
Yeah.
straight.
Yeah.
Oh,
I'm just trying to see how destruction.
So I open a block, I create a new instance of line called L, and I pass no arguments. So that's going to invoke this function here. So invoke the, just for consistency. So invoke this default constructor.
Oh, yeah.
So this is creating a new instance of line.
Yeah.
So we use that, whatever code we might have in here.
Yeah.
And when we hit the closing brace, when we exit this scope,
Oh yes. Okay.
then the destructor of this line instance gets run. It calls this function here.
I see. And where is the if else? If you want to make it. You're putting the if else in the red.
In the red bit,
Yeah.
if else in here.
Yeah.
So do you it's called multiple times for each? It gets called for each time given you define the line. Yes. Is that right?
yeah.
It sort of makes sense because each time.
Okay, so now we've got a slightly more complicated block. These my closing curly braces are starting to look like three. So now we have some if condition. But again, we're going to call line L with one brackets.
Because I've got so many.
This is exactly what we had before.
Eight.
When we create the line in this block, we hit this closing curly brace here, the line gets destroyed in the structure.
Line.
And the else.
Yes.
Yes, that's what that was my question.
But it's calling the constructor. This is a function definition, right? So this calls this function.
Yeah.
And when we reach this point, the compiler automatically calls this function, whether we like it or not.
You can't call another function. I'm like, what would we put if we put it above it without even scope?
Well, you've got to imagine that these are in different files. So this is in some file over here, and this is some code. This defines our line. It's part of the definition of our line, how the line works.
Yeah.
And this is some code that uses.
Yeah. It seems quite limited that you either use the line in the if or you use the destructor. It seems like it would be nice to have another class that you could reference, but that's not possible.
I'm not sure I follow quite.
So we use line, we reference line in the if.
Yeah. So we're creating a new line in here. In the
And then the else is the destructor.
no. So instead of writing it like this,
Do you know what?
I'm just going to imagine that there was no else block.
What's the last line?
So now we have if something. Let's go to curly brace.
Yeah.
Curly brace which opens the block.
scope.
So
When we exit the scope,
they weren't
So
you have
any local variables get destroyed.
Yes.
Yeah. So now,
the function.
put it on a different line.
So
Create another separate scope.
But you, the only thing that's going there is something related to line, or you can leave it blank.
No, I mean we could have a float in here, we could have a string, or whatever. This is, imagine this is a completely separate piece of code to the line definitions. This is some other code that uses the line class.
Yeah. I mean, the float string is quite basic. I'm just thinking of something equally as complex as your line class.
Oh, well, imagine a standard vector, which is very, it's anything but simple.
You can do that.
Of course, you can define whatever type of code you want. It's completely separate to the line.
And if it's blank, it'll just destroy it. It'll just use its destruction.
If there's nothing in here, there is nothing to destroy. There are no new variables anymore.
the idea of delegating in JavaScript that I'm aware of is the concept of it's a concept of the inheritance.
Is it created line inside it?
Different
I think I'm just too tired. I'm not saying this is separate code. This is line CPP. This is
the analogy.
Somewhere at the top has
a prototype so you go around it. That's the
It does think it's yeah. It just
we need to go this and then if you
I don't want to
video.
Yes. So if you go to on YouTube, I can't remember the URL, but you can just search for C++ language on YouTube, and you'll have all our past videos on this. Is this your first time? Yeah. So I've just got Turco videos. I've just got to turn off this stream. But
everybody, thank you very much. Big thank you to Tristan for the class. That even we managed, even with the, we did manage to overcome that. So just a quick reminder, I set up the page GoFund. Yes. So you're very welcome to join us and help so we can get a replacement machine for Tristan. And obviously, I think invite everybody to join us in a
the structure is deleted private.
Pint or two.
If you leak the object, that works, right?
New
whatever, and then just leak it.
on Tuesday. Thanks.